Dear colleagues, I'm very honored being part of this very prestigious panel, and I'm going to present you, as I have been requested, a paper that have stimulated my interest in vaccine immunology. The first paper I'm going to show you, it's not the one that I'm going to discuss, but still it's a landmark paper that has been published in The Lancet at the beginning of the century and describes the impressive effect of vaccinating South African gold miners with a pneumococcal vaccine. And what the authors show in this paper is that the vaccinated group was protected. The efficacy of the vaccination was 50% against death for the 6 months after vaccination. And the impact of this paper in the public health interventions was so high that the pneumococcal vaccine has been recommended for every person being at risk for pneumococcal pneumonia. 30 years ago, I went to UK to do my fellowship in infectious disease. And at that time, I was very excited that I have been offered the chance to do a study on pneumococcal vaccine in HIV-infected children, on the immune responses in HIV-infected children. And at that time, I attended a lecture by Professor Charles Gilkes, who was doing research in Africa, and he was studying the efficacy of a pneumococcal vaccine among HIV-infected adults in Africa. And I was very surprised to hear that the steering committee of the trial asked him to stop the study because there was evidence for some harmful effect that the vaccine could have in the group that have been vaccinated. And being very sensitized by the Hippocratic oath that first do no harm, I was very interested to see the publication, to read the publication that came a few years later in The Lancet, where they described the study and their findings. And what actually they show is that it was a very simple study, 1,392 HIV-infected adults. At that time, there was no antiretroviral treatment, so these people are very immunocompromised and at very high risk for dying from pneumonia. And half of them received the polysaccharide vaccine that was available at that time, and half of them received placebo. And the study had as primary endpoint to the first event of invasive disease and other secondary points that shown in the slide. And of course, the results were surprising. The all-cause pneumococcal pneumonia and all-cause pneumonia cases were higher in the vaccine group compared to the placebo. Of course, the vaccination did not have any significant effect on survival of the participants. And some more data. You can see here in the table that in all vaccine serogroup specific cases of pneumonia were double in the vaccine group compared to the placebo, and all-cause pneumonia similarly accumulation of cases in the vaccine group. The good thing was that this event was observed immediately after the intervention, and 6 months later everything went back to normal with regards to the incidence of pneumococcal events. So the main points of discussion was, of course, that although it has been designed to show a positive effect, because previous studies using not the correct methodology has provided some evidence that the vaccine could be effective, the results were not what was expected. And of course, what was more interesting was evidence of vaccine-associated harm. And what the authors mention is that this detrimental effect appeared specific with impaired anti-pneumococcal pneumonia immunity, and tried to give an explanation at that time, and they said that it shouldn't be the thing that the vaccine is not immunogenic, but something should have been done with the polysaccharide-specific B-cell clones that could have the vaccine had an effect on them. So what I've learned from that paper is that, first of all, guidelines lacking evidence should always be challenged because they may be wrong. The second one, which was obvious, is that vaccines work differently in specific population, and studies to do vaccines in this sort of population are very difficult to show statistically significant results. So, but still, we have to have them, and sometimes pharmaceutical companies do not provide the resources to do this sort of difficult studies. And finally, this potential harm that could be associated with a vaccine antigen stimulate my interest to be able to try to understand the complex interplay between the vaccine and the immune system and how this defines vaccine efficacy. So going back to Greece, and being also responsible for many different groups of immunocompromised patients, I started doing studies in this populations, and I was lucky enough, my first paper from Greece, published at the JID, with this paper I got the ESPID Young Investigator Award for the year 2000, and I was very proud for this award from ESPID. The other thing that I would be interested to investigate was the effect of antigens on B memory cell induced by vaccination. And just briefly to remind you is that B memory builds two walls of protection against pathogen. The first one is the circulating high avidity antibodies, but this first wall have some holes, and if the pathogen enters these holes, it will face another wall of protection, which is the antigen-specific B memory cells, which are there, they are long-lived, and they are ready to produce quickly antibodies to fight the pathogen. So we would like to see how different antigens affect this second wall of B memory cells. And what we saw is that using conjugate or polysaccharide pneumococcal formulations, you can have very different effects on this wall. And you see how enriched is this population when we give conjugate vaccines, and how depleted is when you give sequential doses of polysaccharide vaccines. These findings were also confirmed also from other groups, had a quite significant impact on changing guidelines for immunocompromised, on HIV-infected patients, and then there was a suggestion that the practice to give a repeated dose of polysaccharide vaccine is not recommended anymore. They use it very, very carefully and prefer the conjugate formulations. And from what I already said, it's obvious that one size does not fit all. It's obvious that vaccination strategies for the high risk should be personalized. And I think that's also obvious that decoding the secrets of vaccine immunology will pave the way towards this these better vaccination strategies. And in my last slide, I want to mention what Professor Claire Ann Zigrid's, the first professor of vaccinology, says in her article, How Successful Vaccines Will Help Us, Teach Us How to Induce Efficient Protective Immune Responses. What she says is that by deciphering the biological basis for the efficacy of existing vaccines, we will have the knowledge in order to develop optimal vaccination strategies for immunocompromised patients. And since we are entering the golden era of precision vaccinology, I think that all this research is going to pave really the way toward development of more effective vaccines for population who most need it. And in conclusion, in this Forgotten Wisdom session, I would like to mention 4 things that should not be forgotten, actually. The first one, that we have to challenge whatever dogma is not scientifically evidenced and try to prove if it's right or wrong. The second one is that we have to try to understand our research findings, because it's crucial in order to push the borders of science. And finally, is that surprising results in research is not always a bad thing. Sometimes they can be enlightening because they provide valuable insights and opportunities for new discoveries. Thank you.